Hi everyone, welcome to Mr. Wagged's math class. We have been talking about reading and analyzing data using different displays. The most popular one that we already know about is a pie graph. Just looking at the graph, I know the blue, which is the percentage of male, is more than the percentage of female. The second display was a scatter plot. Dots are scattered all over the place, trying to find if there's a relationship between the X and the Y values. Histogram, also another way to display data. We already talked about a graph that shows the oven temperature over time. And another way to display data is a bar graph. The purpose of organizing data in different displays, first of all, it makes it easy to read. Or maybe find a relationship between the data, and at the end, draw conclusions about the relationship. Here's the first example of today's lesson. I randomly surveyed 66 of my 8th graders whether they like school lunch the way it is or not. I used this form because, everything is online now with this pandemic. I asked only 2 questions. The gender, whether male or female, and if they like school lunch or not. After the survey is done, here's the survey results. I downloaded it as a spreadsheet. And it shows the gender and whether they like school lunch or not. Male, yes, male, no, female, yes, male, yes, and so forth. 66 people answered this way. Is it easy to read when it's displayed in a spreadsheet like that? Absolutely not. So how would you organize this data to make it easier to read and then find a relationship if it exists and draw conclusions? So I took the data from the spreadsheet and I organized it in a table. This table shows the male and female who like the school lunch the way it is, and then another table for the male and female who did not like school lunch. And then I counted using tally marks. Number of males in each bundle is 5, and number of female with a tally mark. Again, for the second table, same thing. Number of males using tally marks and number of female using tally marks. Now it's easier to see how many people like school lunch and how many people did not like school lunch. But still, I can make it much easier to read using numbers. So now here's the tally marks from the survey, and I am going to organize this data in something called two-way table. To construct a two-way table, watch this. Make a rectangle first. Then think about your categories. Your first category is lunch preference, and the second category is the gender. Now think about the subcategory. Lunch preference, whether they like the lunch or don't like the lunch. And I need a total column. Now let's talk about the gender. There is male and female, but again, I need a row total. Now let's look at those little tables and count the tally mark for each one. I can see that the number of males who like the school lunch are 16, and the number of female who like school lunch are 12. The number of male who do not like school lunch, 21. Number of female who do not like school lunch, 17. Now let's fill out the total column and row. The total male is 16 plus 21 is 37. Those are the total males surveyed. And the total number of females surveyed is 12 plus 17, which is 29. Now let's fill out the total people who like school lunch, which is 16 plus 12 is 28. Total number of people who did not like school lunch, 21 plus 17 equals 38. Now you're left with this square empty. What is that square? And pay attention to that square, because this will tell you if you counted your data right in the table. If I add the total, 37 plus 29 will give me 66. And if I add the total of like and don't like lunch, 28 plus 38 also gives me 66. So that number, 66, is the total number surveyed. If that number matches the number of people you surveyed, which is 66, that means you got your data correct. Now there are two vocabulary words that you need to learn about two-way table. Here's the two-way table. There's too many numbers. You have the 4 numbers in black in the middle, and you have the total numbers in red. So the first vocabulary word is joint frequency. And joint frequency are all the numbers that joins both category inside the table, which means all the black numbers that joins the category of gender and lunch preference. Let's see and explain or interpret each joint frequency. The joint frequency 16 represents the 16 male students like school lunch. And 21 is the 21 male students do not like school lunch. 12 is the 12 female students like school lunch. And 17 is the 17 female students do not like school lunch. Watch how I used both categories to explain each joint frequency, the numbers written in black in the table. Now the second vocabulary word is marginal frequency. Marginal frequency are all the numbers in the total column and row. The first number is 28, and 28 is the total students who like school lunch. 38 is the total students who do not like school lunch. 37 is the total male surveyed. 29 is the total female surveyed. And 66 is the total students surveyed. When I interpret or explain the marginal frequency, I only talk about one category at a time. When you're talking about joint frequency or explaining the joint frequency, you are combining both categories to explain each number. Now we need to find the percentage of each joint frequency to draw conclusion. Here is the two-way table. We need to find the percentage of each joint frequency. To find the percentage, you divide the part divided by the whole times 100%. The part we're talking about is the joint frequency, and the whole we're talking about is the total people surveyed. So the first joint frequency is 16, the number of male who like school lunch the way it is. If I take that 16 divided by 66 times 100% gives you 24.2%. And if I take the 21 joint frequency divided by 66 times 100 gives me 31.8%. And put that in the table. And if I want the number of female who do like lunch, 12 divided by 66 times 100 gives me 18.2%, and put that in the table. And the number of female who do not like school lunch is the 17 divided by 66 times 100 is 25.8%. So here's your percentage table. Makes it again easier to read and draw conclusions. But now let's fill out and make sure what I did was right. So I'm going to fill out and add the total percentage and make sure they make 100%. So if I add the 24.2 plus 31.8 is 56%, 18.2 plus 25% gives me 44. And if I add the 24.2 plus 18.2 is 42.4%, and the 31.8 plus 25.8 is 57.6. Now, does it make 100%, which is the total surveyed? 56 plus 44 is 100%, and 42.4 plus 57.6 is also 100%. Because I got that 100%, I know I got my percentage correctly. Now let's draw a conclusion and see if there is a relationship between the gender and the lunch preference. So here's the table. Is there a relationship between gender and lunch preference? Do they like the school lunch? Do male or female like the school lunch more? Do they both like school lunch? From the percentage, I can draw conclusions. I can say yes, both male and female do not like school lunch because 57.6% of people surveyed, whether male or female, do not like school lunch. And that is more than half. Here's another example for today's lesson. The two-way table is already made for you. Does the table show a relationship between age and whether students ride the bus to school? So the two categories are the grade level and ride the bus to school, whether they do ride it or don't ride it. You have 6th, 7th, and 8th graders. For me to draw conclusions, I need the percentage. So to find the percentage is, again, the part divided by the whole times 100%. But since I'm asking about each grade level separately, then the whole is the total grade level student surveyed. So if I wanted to find the percentage of 6th graders who ride the bus, I will take that 24 divided by the total, which is 40 of 6th graders surveyed, times 100% is 60%, and I put that in the table. Now, what if I want the percentage of 6th graders who do not like school lunch? Then I will take the 16 divided by the total 6th graders surveyed, which is 40, times 100% equals 40%, and put that in the table. It's going to take a long time to do every single one, so I already filled the table with the percentage for each grade level. Now look at the table filled out with the percentage. Can you draw a conclusion? Can you find a relationship between the grade level and whether they ride the bus to school or not? I can look at the percentage of who do not ride the school bus. It goes from 40 to 52 to 60, which means the higher the grade level, the less likely they will ride the bus to school. Of course, there's different ways to say that. You can also say the less the grade level, so if you go to 6th graders, the more likely they would ride the bus. So you can word it however you want it to, as long as you can find that relationship between the two categories, which is grade level and whether they ride the bus to school or not. So in conclusion for today's lesson, tally marks are not easy to read. Constructing a two-way table with the numbers are much easier to read, to draw conclusions and find relationship between two categories. Remember, the two vocabulary words are joint frequency, which is the numbers that joins both categories together, and the marginal frequency, which is the total column and row. The last number in the corner is the total number surveyed. You need to find the percentage table from the two-way table using the part divided by the whole times 100%, which helps you find a conclusion or a relationship between the two data in the two-way table. That's it for today's lesson. Thank you so much for subscribing, liking, and commenting on my video. See you next time. Have a great day.